more examples to look at. So I said when we had an extra variable, there's some extra steps like the last problem. But if we look at these problems, we'll notice that we've got an index and a power under the square root, or we'll notice that we have a fraction as an exponent. So anytime we see these patterns, we need to convert from radical form to exponential form, and that's going to allow us to solve. So the first one I noticed has a radical, so I'm going to convert it to exponential form. So I have that 3 in front, I'm just copying down, and then I have x plus 1. Well, remember my index, that 5 as my index right here, that becomes my denominator, and then the power on the inside, that 3, becomes my numerator in the exponent. And then I have plus 1 equals 25. Okay, so just like we practiced isolating the radical, we want to isolate the part with the exponent. So I'm going to subtract this 1 over, so I get 24. And then I see this 3 out front, I can divide by 3, so those 3's cancel. So I'm left with x plus 1 to the 3/5 equals 8. Okay, here is something slightly new. So we were used to doing, if we had the square root of x, we knew the opposite operation was to square it. Well, we could rewrite that as x to the 1/2, and the opposite was squaring it. 2 is just like 2 over 1. So when we have it as a rational exponent, when it's a fraction, we need to flip the fraction. That is going to allow the fractional exponent to cancel so that we are, in a way, eliminating the radical. So since we have 3/5, I'm going to raise this side to the 5/3. And since I'm doing that on the left side, I have to do the same thing on the right side. So these now cancel, and I'm left with just x plus 1 on the left side. On the right side, I have 8 to the 5/3. So we can think about converting this and figuring out what it simplifies to that way. Or if you would like, this is where you can use Desmos or another calculator to help you. So I need to figure out what 8 to the 5/3 is. So if I type it in, I see I get 32. However, we need to be aware of the fact that this is got a radical. So if I look back at the way I wrote it here, that radical means that I'm not just going to get a positive value, but it could also be the negative value. So a way that you can think about that is if we have positive 2 squared or negative 2 squared, both of those give us positive 4. So we need to take the positive and negative values of the answer to account for the fact that it could be the original positive or negative value. So if we write plus or minus 32 here, what we can do is split this into 2 equations. So we have x plus 1 equals positive 32, or x plus 1 equals negative 32. That is what's going to allow us to get 2 potential solutions. So if I subtract 1 on the left side, I get x equals 31. Or on the right equation, if I subtract 1, I get x equals negative 33. So from here, these are our 2 potential solutions. But remember, we always need to check. So let's check it out. All right, we can plug this back into our original equation if we like. Or if we want to make our work a little simpler, we can pick one of these iterations here where we've been simplifying. So I'm actually going to choose x plus 1 to the 3/5 equals 24. Oh, excuse me, that was equals 8. I'm going to pick that to plug into because that's way easier to check my work with. So again, I just picked that from this line right here before we did the writing in black, what we had gotten in green. Okay, so I'm going to plug in each of them. So I have 31 plus 1 to the 3/5. I'm going to see if that equals 8. Or negative 33 plus 1 to the 3/5. And does that equal 8? So I'm going to get 32 to the 3/5 or negative 32 to the 3/5. So we can again convert that to radical form to simplify or utilize Desmos. So 32 raised to the 3/5. I see I get positive 8. So for my first one, 8 equals 8. That's exciting. That means that x equals 31 is a solution. And then the next one is negative 32. So when I type that in, I want to be careful to use parentheses. And then raised to the 3/5. And when you look at that, we get negative 8. So for that one, because we get negative 8 does not equal positive 8, so x equals negative 33 is not a solution. I know that that felt longer, but let's try one more altogether to see if that helps. So we noticed in this problem we had a radical to begin with, so we needed to change it to exponential form. Sometimes we might solve equations that don't have the radical, but we'll notice they have a rational exponent. So what we want to notice is if the exponent is a fraction, then this is going to lead us to needing to do the flip the fraction thing. Okay, so first I want to isolate the stuff, I guess I'll say, the variable or the terms with the exponent. So in this case, I don't have any parentheses, so it's just the x that's raised to the 3/2. So we're going to work on isolating that. First, I'm going to add 5 to each side. And then I can divide by 4. My 4's cancel, so I have just x to the 3/2 equal 27. All right, this is where we think of, I guess step 2 is flip the fraction. So I'm going to flip it to 2/3, and whatever I do on the left side, I have to do on the right side as well. So the flipped fractions, the reciprocals there cancel. We just get x equals 27 to the 2/3. So again, if you'd like to convert it to radical form, you can simplify it this way, or you may use Desmos or another calculator. Just remember, we always need to consider both the positive and negative values for our answer. So I get 27 raised to the 2/3 equals 9. All right, now we need to check our answers, excuse me. So I'm going to take that and plug it back into my original equation. Again, I can plug it into the original. I can plug it in after I subtracted 5. Any of these steps, because it's the same equation, since we've done the same operations on each side, it's stayed balanced. So I'm actually going to pick this line because it's the most simple and it's going to be the easiest to check. So I have positive 9 raised to the 3/2 equals 27, or negative 9 raised to the 3/2 equals 27. Those are what I want to check. I'm going to use Desmos to help me. So 9 to the 3/2 gives me positive 27, so this is good. So x equals 9 is good. And then if I try negative 9 raised to the 3/2, it tells me it's undefined. So that value does not exist due to the negatives, or at least it's undefined. So that's not good. That means x equals -9 is not a solution. We can write that it's extraneous. Great job, everyone.